Okay, so when we talk about factoring, almost everything that we can do, we can factor something out of it. But there are some polynomials that cannot be factored, and they're called prime. Now, there are very few on your worksheet, if any at all, that are prime. So we can always do something to them. So the very first thing that we always do when we try to factor is we look to see if they have something in common. So it says factoring using the greatest common factor. Use this method with any number of terms and try it always first. So we're just going to see if there's something in common. Could I divide something out of 10a cubed b squared plus 15a squared b minus 5ab cubed? There's a 5, right? Every one of them have a 5 in common. And then I have an a cubed, an a squared, and an a. You take the smallest exponent out. So I'm going to take an a out. And then I have a b squared, a b, and a b cubed. And so I'm going to take a b out. Now think about if I were going to divide every one of those three terms by 5ab, what would be left? 2a squared b plus 3. I had two a's, I took one out, so I've got one left. I took a b out, so I don't have anything else with him. Minus 1. I took an a out. I had 3 b's, I took one out, so b squared. Does that look familiar? Now, how could you check to make sure you did it right? We could just multiply it back out, right? Distribute like we just did on our homework last week. I could multiply it back out and see that I get to 10a cubed b squared plus 15a squared b minus 5ab cubed. Okay? Alright, so now we're going to play the switcheroo game and practice greatest common factoring. Okay? So turn the page and go to this guy right here. So in our notes, we pulled out a number and some variables. Sometimes it's just a number they have in common. So we're just going to be working here in this chunk here, a. So if we look at that first one, I have 8x plus 16. What do they have in common? 8. So what do I have left? How about 24x minus 18? And what do I have left? 4x minus 3. All right, you try C, D, and E. Just those next three. And once you get those three done, check them. They're up front. So we always check to see what do they have in common. We're always going to do that first. Sometimes after we do what they have in common, we can do another method with it. Okay? Are there questions on the greatest common factoring? Okay. I'm going to leave the second column F through J if you feel like you need more practice. Okay? All right, so let's go back to your notes. So the first thing we always look for, do they have anything in common? The second thing we do is see how many terms they have. When there are two terms, try one of the following methods. All right, well, so we have the first one. They're in a box here. You just have to memorize the pattern, okay? So the first one we have is the difference of two squares. So if I have two perfect squares, a squared and b squared, and I'm subtracting, then it separates into a plus b and a minus b. For example, x squared minus 16. Is 16 a perfect square? Yes. What is the square root of 16? Bless you. 4. So I'm going to factor this guy. I take the square root of both. Well, the square root of x squared is just x. So I get x plus 4 and x minus 4. All right, let's save the cubes for a minute. Let's just keep looking at those guys. That's all I can do. Okay? What happens there is that when I multiply this guy back out, I get x squared and a negative 4x and a positive 4x. So those 4x's cancel. That middle term cancels. And then I get the minus 16. Okay? So that's all I have to do if I have a difference of squares. I just have to take the square root of both. One's a plus and one's a minus. Okay, playing the switcheroo again. Go back. Now we're in chunk B. Sorry for the switcheroo on you. So this one says x squared minus 81. Is 81 a perfect square? What's its square root? 9. So this guy's going to factor x plus 9, x minus 9. Could I have written it as x minus 9 and then x plus 9? Yes, you certainly can. So just one of them's a plus and one of them's a minus. How about b? X squared minus 49. What's the square root of 49? 7. How about 196? Thomas?
It's 14.
Awesome, thank you. How about 4x squared minus 25? Thomas, you want to go for it?
It's 2x plus 5, 2x minus 1.
Awesome. So we take the square root of 4 as well, so we get 2x plus 5, 2x minus 5. And then we have 49x squared minus 36. So we decided square root of 49 was 7, so 7x plus 5, 7x minus 5. No, 6. Yowzer, lady. Okay, this time I want to look at this column over here. Because it's in this whole chunk, that talks about the difference of squares. But if you look at f, it's no longer a perfect square. So what do we need to do first? Does it have something in common? An x. So we're going to pull it out. So I'm left with x squared minus 25 now. Is this guy now a difference of two perfect squares? Yes. So see how you might have to do something first and then do another method. So this guy now becomes x times x plus 5, x minus 5. Letter G is one of the most I don't know how to say this. You'll see this one again, okay? In fact, you even may see this again on your test. This one is a great difference of squares problem. So make sure you know how to do G. Is 1 a perfect square? Yeah, its square root is 1, right? So does anybody want to take a stab on how that guy might factor? Thomas, go for it. Yeah. All right, now I'm going to show you something else. Are either one of those two guys a difference of squares? Yes, so we can do it again. So we're trying to break this guy down to as small of a part as we can go. So this guy right here is a difference of squares. There is no formula for the sum of squares. So he's going to stay x squared plus 1. But now I'm going to break this guy apart into x plus 1, x minus 1. Like I said, put a box around that, highlight it, square it, star it, I don't know, draw arrows towards it. That one you will see again. Okay, what about H? 63x squared minus 112. Are 63 and 112 perfect squares? Is there some number that I could divide 63 and 112 by? Isabel's trying. She's like, maybe. What do you think? 7? Let's try it. 112 divided by 7 is 16. So if I take a 7 out, I get 9x squared minus 16. So now that guy factors, he's now the difference of squares. So I have 7 times 3x plus 4. 3x minus 4. Thomas.
That's actually a pretty easy way to find out divisible by 7.
Yeah, tell me.
You take the last digit,
Uh-huh.
you multiply it by 2, and subtract it from the top one. So you take the 2, multiply by 4, and 11 minus 4 is 7, and that way you divisible by 7.
No way.
I learned that in 5th grade, and I still remember it somehow. It works for any number.
So,
Keep getting it.
so like, okay, so does it work for 2 digits too?
Yeah. But actually,
But it definitely works for 3 digits.
it doesn't work for 3 digits and above.
Oh, it works for 3 digits and above.
Because you just have to do it again and again.
Oh,
And then you kind of just do the one.
pretty sweet. I'm gonna have to remember that one.
It's also a way to figure out why 11 or 13 are not those.
Wow, I'm gonna have to check those out. That's the first time I've heard the 7 one. That's awesome. Yeah, I'm gonna have to research that. That's pretty sweet. Okay, so try A, I, and J. You try the next two. See if you can get the next two figured out. They have a number in common. Okay, questions on difference of squares? So for I, you should have gotten 2 times 5x plus 6 and 5x minus 6. And then for j, you can pull a 5 out, so you get 5 times x plus 4 and x minus 4. Okay, switcheroo. Let's go back to your notes. So we talked about the difference of squares. And as we talked about, there's no sum of squares. However, there is a sum and difference of cubes. These ones you've probably never seen before. You just have to memorize the formula for these. Okay? I'm going to draw a little squiggly. With the sum of 2 cubes, a cubed plus b cubed, you drop the cubes off, so you get a plus b. And then I look at this guy and I square him. I flip that sign. I multiply them together, and then I square it. So I have a squared minus ab plus b squared. If you notice, these two are almost essentially the same exact formula. The only thing that changes are where the signs are. So that guy's a plus, that guy's a plus. That guy's a minus, that guy's a minus. That guy's a plus, that guy's a minus. Do you see that? It's the same formula. So if you just remember the formula, you should be okay. Alrighty, so x cubed minus 27. We need to write 27 as a cube. Can I take 27 and write him with an exponent of 3? What would it be? So in my formulas, you can think about as x being a and 3 being b. See that? If it helps, and now I'm just going to follow the formula. So this guy factors into x minus 3. And then I take my a and I square it, so I get x squared. And then this guy's a minus, so he becomes a plus. I multiply my a and b together, so I get 3x. And then I get a plus 3 squared, which is 9. The nice thing about factoring the sum and difference of cubes and the difference of squares is that there's nothing else to do to it. That's all that it does. You just use the formula. Okay, there's no sum and difference of cubes on the other worksheet, so let's keep going with the notes, okay? Alright, when there are 3 terms, try one of the following methods. The first one is a perfect square trinomial. Those guys, they're nice if you see it like that, but really what I want to do is talk about just 3 terms in general, and how do you factor general trinomials, okay? I use what's called the trash method. Does that mean this is the only method there is to factoring? No, this is what I use. The nice thing about knowing this method is that it takes the guesswork out. Remember back in the day and you were doing some X's, right? They gave you the little X charts and the diamonds and you had to put the guy on top and figure out was it positive, negative, you know, did they add and subtract together? My sign chart here will help us figure that out together. Does that make sense? So it takes some of the guesswork out of who's positive and who's negative. So, if my trinomial has a plus and a plus, my answer will have a plus and a plus. If my trinomial has a plus and a minus, my answer will have a plus and a minus. Notice, when it starts out with a plus, my answer has the same signs as my trinomial. If it has a minus and a plus, when I factor it, it will be a minus and a minus. If it's a minus and a minus in my trinomial, then it will factor into a minus and a plus. Notice when it starts out with a minus, the second one flips. Okay, so when I look at number 4 here, it says factor 4x squared minus 5x minus 9. The first thing I'm going to do is figure out my signs. So it's a minus and a minus. So in my answer, it's going to be a minus and a plus. So give yourself some room because we need to fill things in. So I'm going to figure out my signs first. The next thing I'm going to do, there's a number out front of my squared term. I'm going to put that in both of them. And some of you are going to say, hold on, lady, when I multiply that back out, I'm going to get 16x squared. Yes, I know. Hold your pants on. We don't know if it's 2 times 2 or if it's 4 times 1. So it's going to fix it for us. Okay, the next thing I'm going to do is I'm going to multiply 4 times 9. What's 4 times 9? 36. Okay, now I'm going to show you your little xy thing. I want 2 numbers that when I multiply them I get 36, but I subtract them and I get 5, my middle term here. Now, it says negative 5 there, but my sign chart's going to take care of. Figuring out the signs is already going to figure this out for me. So give me 2 numbers that multiply to 36. Subtract to give you 5. Thomas? 4 and 9. Put the bigger number first. When we put the bigger number first, it fixes it to get the sign that we want in the middle. We wanted a negative 5, so now I have a negative 9. Perfect. Okay? Now, we've put that 4 into our answer one too many times. So I'm going to look at my factors now, and I'm going to see, do they have anything in common? Do 4 and 9 have anything in common? No. How about 4 and 4? Do they have anything in common? Yes. I'm going to divide it out and throw it in the trash. And this is why I call it the trash method. So I'm dividing a 4 out of there. So I'm left with 1x plus 1. Okay, let's do a quick little check to make sure it worked. Quick little check means I'm going to FOIL really quick. 4x times 1x gives me 4x squared. Perfect. 4x times 1 gives me a positive 4. Negative 9 times 1 gives me a negative 9. So I have negative 9 plus 4 is a negative 5. Negative 9 times 1 is a negative 9. Success, we've done it. Okay, let's try another one. Number 5 here. I have x squared plus 7x plus 6. First thing we're going to do, figure out your signs. So I have a plus and a plus. My chart says my answer is going to have a plus and a plus. This guy had a coefficient of 4 in front of my squared term. This guy has a coefficient of 9. It makes my life just a little, or 1, right? Makes my life just a little bit easier. So I'm just going to put a 1x in both of them. Multiply the first term times the last term. 1 times 6 is 6. I need 2 numbers that multiply together to give me 6. And now they're going to add to give me 7. How come did we subtract them over here but they're going to add now over here. Thomas, what do you think?
Because the first sign is a plus.
Yeah, these guys have the same signs. Okay? So if my answers have the same signs, they're going to add to give me my middle term. These two guys had different signs, and they're going to subtract to get my middle term. Okay, so here I'm going to write add, subtract. Add, subtract. So give me two numbers that multiply to 6. Add to 7.
1 and 6.
Do a quick little check. X times x is x squared. I have 1x plus 6x's is 7x. 6 times 1 is 6. Okay? Yes, ma'am. No, but she's at home online. Yes, she's there. Uh-huh. Yep, bye.
Is that right? Is you add the subtraction in? Because I thought we just subtracted it.
Which one?
The third one. Is it add or subtract?
This one will be add. So,
Didn't we just do that one though? And it was subtraction. No, never mind.
it was this guy. So we did a minus here.
Okay.
Yes. Good question. Okay, you ready for another one? Questions? Okay. Number 6. I have m squared minus 18m plus 81. All right, let's figure out our signs. Minus and a plus. So I got a minus and a minus. All right. I'm gonna put a 1m. If you don't want the 1 there, you don't have to. 1 times 81 is 81. So now I need two numbers that multiply to 81. These signs are now the same, so they're gonna add to give me 18. What if you're not sure about factors? Have you seen this trick? Let me show you something. So, say for example you weren't sure of the factors of 36 or 81, okay? Your calculator will give you a list of factors. So if you go to y equals, I've got a whole bunch of junk in there, but it doesn't really matter. We're not going to graph it. And you take the number that you're looking for. So I'm going to do 81, and then I'm going to divide it by x. Then if you hit second graph and go to the table, it's hard to see. But this is a list of all of the factors. 1 times 81. Well, that doesn't add together to give me 18. 3 times 27. That gives me 30. I want to add to 18. 9 times 9 is a factor of 81, and those two add together to give me 18. So if you're not sure, your calculator will give you a list, and feel free to do that. Okay? So when you put it in your calculator, you just go to y equals, take whatever number you're looking for, and divide it by x. All right, so this guy's 9. and 9. So I get m's minus 9, m minus 9. You're welcome to leave it like that. When you have two of the same factors, you could also write it like this if you want. You don't have to. Okay, let's try this one here on our notes. Nine y squared plus 30y plus 25. We have a plus and a plus. So what are my signs going to be? Plus and a plus. Now again, factors of 9, it could be 3 and 1, or 3 and 3, or 9 and 1. So I'm going to put a 9y in both of them. Multiply 9 times 25. $225. I don't know about you, but I'm not really up on my factors of 225. These two signs are the same, so they have to add to 30. So let's use our calculator. I'm going to take 225 and divide it by x. Oh, I don't want to grab it. Stop. Three and 75. 5 and 45. 9 and 25. Well, that's closer. We're at 34. We just want to get to 30. 15 and 15. All right, now remember, if we were to multiply this guy back out, we'd get 81y squared. And I don't want 81y squared, I just want 9. So I put a factor of 9 too much in there. So I'm going to look to see 9y plus 15. Do they have anything in common? It was 25 and 9 though.
Oh, it's 225.
225, yep. Do 9 and 15 have anything in common? 3, yeah, let's divide everybody by 3 and I'm going to throw it in the trash. So I get 3y plus 5. And then I have to do it out of this guy too. Again, you could write that as 3y plus 5 quantity squared if you want. So, sometimes you have to trash a factor out of one set of parentheses. Sometimes you don't have to do it at all, and sometimes you have to take it out of two different ones. Now, this one we took a 3 out. Sometimes you'll take a 2 out and a 3 out of one or something like that. So you don't have to take the same thing out of both. Okay? All right, let's try some. So go back to your worksheet. We're in chunk C now. I'm going to put the sign chart right there so we have it right next to us. So I have x squared plus 8x plus 16. What are my signs going to be? Plus and a plus. There's no number out front, so he's just a plain old x. You could put a 1 there if you want. Give me two numbers that when you multiply them together you get 16. The signs are the same, so they add to give you 8. Bye, Thomas.
4.
4. Yeah. Thank you. Okay, letter B. I don't have a number out front, so I'm just going to say X. I have a minus and a plus. A minus and a plus is a minus and a minus. Give me two numbers that multiply together to give you 36, but I add them and I get 12. Sasha says 6. Again, you could write those ones if you wanted, like x minus 6, the whole thing squared. You don't have to, though. Okay, letter C. I have x squared minus 14x plus 49. I have a minus and a plus, so it's going to be a minus. And a minus, there's no number out front. Multiplies to 49, adds to 14.
So you're cutting out a lot.
Oh, am I? I'm sorry, honey. I'll try to talk Atu more. How's that sound? I'll try to look at the computer. All right, letter D. I have x squared plus 10x plus 25. I have a plus and a plus, so it's going to be a plus and a plus. Multiplies to 25 and adds to 10. 5. We've done 4, 5, 6, and 7, right? Okay, letter E. X squared minus 26 plus 169. What do you think with that guy? I have a minus and a plus, so I have a minus and a minus. Factors of 169. That add to 13. I just said it. Duh. 26. Okay, so this whole chunk here was those perfect square ones where they ended up being the same factor twice. What I want to do, if you want extra practice, you're welcome to do that column. I'm going to skip over here down in chunk D and do F through J with you. If you notice, these guys all have a number out front. So I want to get in the habit of looking at those ones with a number out front because I think they're a little bit more tricky. Okay? Some of these you might need some extra room or stuff to write on. So the first thing we always do is we look to see, do they have anything in common? So if we look at F there, I have 2x squared plus 3x minus 35. Do they have anything in common? No. So I'm going to go look at my sign chart. And I have a plus and a minus. So what are my signs going to be? Plus and a minus. So I have 2x plus, 2x minus. Give yourself some room because we're going to have to do some trashing. When you have a number out front, you have to do some trashing. All right, now, I am going to take 2 times 35. What's 2 times 35? 70. I need two numbers that multiply to 70. The signs are different, so they subtract to give you 3. Ten and 7. Perfect. Put the bigger number first. I wanted a positive 3, so I need a positive 10. Okay, now you're going to look. Did 2x plus 10 have anything in common? 2. Take it out, divide it out, throw it in the trash. And then 2 and 7 don't have anything in common. So he's 2x minus 7. We did G in your notes, but let's go ahead and do them again, just in case. Extra practice never hurts. I have a minus and a minus, so I'm going to have a minus and a plus. Multiply the first and the last. 4 times 9 is 36. So I need two numbers that multiply to 36, but subtract, because my signs are different, to give you 5. We decided that was 9 and 4. Bigger number first. Four and 9 don't have anything in common. But 4 and 4 have a 4 in common, so I'm left with x plus 1. Then I have 6x squared minus 29x plus 20. Do they have anything in common? No? Okay. I have a minus and a plus, so my answer is going to be a minus and a minus. So I have 6x minus, 6x minus. Multiply the first and the last. 120. So I need factors of 120 that add up to 29. Should we throw that one in my calculator? 120 divided by x. I keep pushing that button. Oy, 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 I'm serious. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24. Is that what we want? Okay, 6x minus 24, do they have anything in common? Yeah, a 6, right? Take it out and throw it in the trash. 24 divided by 6 is 4. So I get x minus 4. 6 and 5 don't have anything in common. 6x. Oh, that's a minus 5. Do a quick little check. 6x squared, that works. Minus 5x, yep. Minus 24x, that's 29x, yep. Plus 20, perfect. Okay, let's do I. First of all, do they have anything in common? An x we have to take out. Alright, so I have an x there, and then I have a plus and a minus, so my sign chart says I need a plus and a minus. So I have 12x plus 12x minus. Multiply the first and the last. 12 times 15. $180. Multiplies to 180. The signs are different, so it subtracts to give me 8. $18 and 10. I want a positive 8, so I want a positive 18. Put the bigger number first, smaller number second. Alright, now I'm looking for things in common. Do 12x and 18 have anything in common? They have a 6 in common, right? So I'm going to divide 12x by 6 and I get 2x. 18 divided by 6 is 3. How about 12x and 10? 2, so I'm going to trash a 2. So I get 6x minus 5. Alright, see if you can do J. Hint, hint, wink, wink. You can take a 3 out. When you finish it, check it up front. You should get 3x times x plus 5 times 4x minus 1. Remember, these guys don't matter the order that they're in, so you can have them flip-flopped. Also, if you know a method to factoring and you like it better than what I just showed you there, do that. Okay? Alright, we have one more method to talk about. And some of you use this method exclusively, and it works for everything, and that's okay. So you can do it with trinomials too. So the last thing we need to talk about is when there's 4 or more terms. You can, like I said, you can also use this method when you're doing trinomials as well. Some of you have seen it before. But it's called grouping. And like I said, on some problems, you have to do multiple methods. So you may need to do another method as well. Okay? That goes for all of these. When we do grouping, you're putting them into groups and pulling whatever they have in common out. So if you look at number 8 there, I have 8ax minus 6x. And I put that in a group, and then I have minus 12a plus 9. Alright, so just look at this guy right here. Do I have something in common I could pull out of 8ax and a negative 6x? 2x, right? Okay, so if I pull a 2x out, I'm left with 4a minus 3, right? Oh, thank you. Where did it scribble? Thanks, Thomas. So I pulled a 2x out, and I'm left with 4a minus 3. I want to look at these guys, and I want to be left with 4a minus 3 again. So what could I pull out of these two guys so that I'm left with 4a minus 3? Sasha says a 3. What else? A negative, right? Now, think about pulling them out again. Essentially, I've changed this guy, so now he, instead of having 4 terms, he's got 2 terms. Here's one term, here's another term. Think about what do these two guys have in common? They have a 4a minus 3 in common. So essentially, I'm pulling it out again. So whatever is in your parentheses, you pull it out. And I'm left with 2x minus 3. Does that make sense? Questions on grouping? Like I said, some of you learn to factor trinomials with grouping, and that's okay too. You can still do that. Okay, that's all of the notes for factoring. Now, let's talk about what do you need to work on for homework, okay? This worksheet number 1 here that we did together and we did some together, that's just note stuff. So if you need more practice, feel free to go back and do those ones. But you might want to write on the top notes. Okay? You don't have to do any more of that unless you want to. The back side of that guy has 2 ginormous columns. Pick one column to do. Okay? You just have to pick one column. That's up to you. Turn the page one more time. This guy right here The printed one, not the handwritten one. I want you to try all of it. I'm going to tell you this is hard. And I know it's hard. Okay? The next several times that we meet, I'm just going over questions. Okay? We're just going to factor and factor and factor. So tomorrow, when you tune into the Google Meet, there's ones that I know that we need to do. Okay? So some of it will be work time, some of it will be me answering questions. Does that sound good? Okay, so your homework is pick one column from the number 2 one and this whole page right here. Okie dokie? Okay. I'm going to stop the recording.